Let's talk about number systems. Natural numbers, whole numbers, and integers. Natural numbers or counting numbers, it starts at 1, then 2, then it jumps to 3, and so on. There are gaps in between these numbers. This set doesn't have any 0, so we include 0 to it and we define whole numbers. So 0, 1, 2, 3 form whole number system. As you can see, these two systems, they don't have any negative numbers. So we add negative counting numbers and we call it integers. Negative counting numbers along with 0 and counting numbers is called integers. Note that we don't have any fraction here. So we define fractions in general form of P over Q. P and Q are integers and the denominator cannot be 0 and we call it rational numbers. The numbers that cannot be written in the form of fraction are called irrational numbers. We take rationals and irrationals and we define real number systems. For example, -4 divided by 7 is an example of rational number. You have two integers divided and the denominator is not 0, so it is rational. Since it's rational, it's always a real number as well. You might say 8 is not a rational number, but 8 can be written as 8 divided by 1. So it is a fraction. It is a rational number, and it also is a real number. Next number is 0.6 with a little bar on top of it. This one represents the repeating decimal. In expanded form, it is 0.6666, and it continues. A short form is 0.6, the little bar on top of it. It is basically the definition of 2 over 3. If you divide 2 by 3, then this number appears. So since you have a fraction of two integers, 2 over 3, it is a rational number. Another number is 0.87, can be written as 87 over 100. Since you have two integers divided together and the denominator is not 0, it is a rational number. Any rational number is real as well. We can visualize everything here. Natural numbers. With 0, we call it whole numbers. With negative counting numbers, we call it integers. So whole numbers include 0 and naturals. Integers include negative counting numbers and whole numbers, which includes natural as well. Rational numbers, which in the form of fraction, also includes integers, whole numbers, and natural numbers. Other than rationals, we have irrationals, square root of 2, square root of 17, pi, Napier number. All of rationals and irrationals form a larger set that we call real numbers. Let's take a look at some examples here. For example, -6. It is not natural. It is not a whole number, but it is an integer. Since it's integer, it is rational. Since it's rational, it is real. Square root of 23, not a natural number, not a whole number, not an integer, not a rational number, but it is irrational. Since it's irrational, it must be real as well. -2 over 7. Of course, it's not natural. It's not a whole number. It's not an integer, but it is a rational number. Since it's rational, it cannot be irrational. Since it's rational, it is real as well. Take a look at 3. 3 is basically a counting number, natural number. Since it's natural, it must be whole. It must be integer. It must be rational, and it must be real. 2.3 with a little bar on top of it. Not a natural number, not a whole number, not an integer. It is rational. Since it's rational, it cannot be irrational. Since it's rational, it must be real. Finally, you can write this in symbolic form. Natural numbers n, which is a set of 1, 2, 3, 4, 5, with examples 2, 3, 5, 17, and so on. Whole numbers that doesn't have the negative values is coming from naturals. Whole numbers represented by W starts at 0, then 1, then 2, then 3, then 4, and so on. Examples 0, 2, 3, 5, 17, and so on. Since whole numbers doesn't have negative, we add negative counting numbers and we define integers with z. There is no smallest number. We just use some negative numbers to represent integers. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. These are all examples of integers. Rational numbers represented by Q, all fractions A divided by B, such that A and B are integers and the denominator cannot be 0. Examples, -17, it is rational because you can write it as -17 over 1. -5 is also rational because it can be written as -5 over 1. So basically any natural, any whole, any integer is an example of a rational number. 2 over 5, which is 0.4, and -2 over 3, which is -0.666, or -0.6 with a little bar on top of it, is an example of rational number. And finally, for irrationals, the symbol that we see in different books is Q to C, or Q complement. Square root of 2, negative square root of 3, pi, negative pi over 2. These are all examples of irrational numbers. So again, if we take all of these numbers together, it is real set. Let's go back to visualization here. Real numbers include rationals and irrationals, and these are the symbols that we are using.